So in this video, we'll be going over a theorem in geometry called Stewart's theorem. And this is a really, not really well known, but it's a pretty important theorem. So, it turns out that not many competition math people and Olympia math people know about this theorem because it's pretty easy to derive this formula on the spot. But for me personally, this theorem really, knowing this theorem and like knowing the fact that I can find this very easily when in my early competition math days, it really helped me with so many geometry problems, in both in competition, simple competition math and in Olympiad math. So yeah, I hope you get a better understanding of this theorem after this video and can apply this in other geometry problems. So yeah, the theorem states that. So we can label our triangle A, B. Oh, that's a really bad B. B and C. And so we label the sides A, B, and C. And let's say we draw a CVN. So realize that I drew a CVN line down here. So a CVN is basically like any line going from one vertex to the other side. So it's just any line going from A to BC. So if we have any CVN from A to BC, then let's say it divides BC into the lengths M and N. And let's say the length of the CVN is D. Then Stewart's theorem says if the triangle has a CVN of length D and it divides the length A into M and N, then it states that, okay, what color should I put this in? Put this in green. Yeah. The Stewart's theorem states that C squared N plus B squared M is equal to D squared plus Mn times M plus N. Yeah, and you can always put an A here, just plug it in, because M plus N is A. But there's not much difference. It means the same thing. So yeah, so that is the theorem. And yeah, it's a pretty useful relationship, because that means if we draw any CVN in a triangle, and then we know like what lengths it divides the opposite side into, then we can easily find the length of this. Or if we know this and this, then we can easily find this, and vice versa. It's actually it's pretty useful identity. Yeah. So and these kind of situations are really common in many geometry problems. So yeah, that makes this more useful. So we're now gonna go over the proof for this. And it's actually pretty simple. So feel free to like try it on your own, and then if you get stuck, then you can come back to this video. So what we're going to do is we're going to divide the triangle. So we're going to look at separate triangles. So we're going to look at this triangle. We're going to look at this triangle, and then we're going to look at this triangle. There we go. Okay, that was a really bad outline, but you get the idea. So we're going to look at these triangles separately, and we're going to say this angle is theta. Then this angle would obviously be 180 minus theta. So just labeling one angle and just getting as much information as we can. So by the cosine rule for, let's call this point D. So for the cosine rule in ABD, cosine of theta, so if we look at cosine of theta in triangle ADB, then let's put this in pink book because we're dealing with this triangle. Cosine theta is equal to D squared plus M squared. Yeah, you guys know the cosine formula, I assume. Minus C squared divided by 2dm There we go. And for the blue triangle, it'll be cosine of 180 minus theta equals d squared minus, yeah. So cosine, by the cosine formula on that on the blue triangle, degree sine, yeah. D squared plus n squared minus b squared over 2dn. And you can kind of see what's going on here because these two equations kind of have some similarity to each of them. So yeah, we might get something out of this. And then what we also know is we know a relationship between cosine theta and cosine 180 minus theta. We know that cosine theta is equal to the negative of cosine 180 minus theta. We know this, so we can just plug these in, and then we will get an relationship between these two equations. So if we plug them in, so yeah, I'll just put them in these colors still. If we plug them in, so we get, and then if we minus this, then this will just become b squared minus d squared minus n squared over 2dn. And then we can realize that we can just cancel out the 2 and the d, because the d is non-negative and non-zero is positive because it's the length. And then we cross multiply to get d squared n plus m squared, oh, that m is really bad, m squared n minus c squared n is equal to b squared m minus d squared m minus mn squared. Yeah. And then this, and then we can, so to get this we can put the c squared n and b squared m on one side. So c squared n plus b squared, okay, my handwriting is getting really bad. C squared m plus b squared m is equal to d squared m plus d squared n plus m squared n plus mn squared. And then this implies, so we can factorize out the m plus n. So this will be equal to, so it will be d squared times m plus n. And then this one is mn times m plus n. So we can factorize it to be d squared plus mn times m plus n is equal to c squared n plus b squared m. And there we go, we get our equation. So yeah, so we've easily found a formula, an easy formula, using the cosine formula. So yeah, so the proof is pretty simple. So that's why a lot of people just do the cosine formula on the spot to find a relationship. But for those who are preferring to like have a formula in mind, then yeah, it'll be good. Then it will help you greatly in some problems. However, really, when you do competition math, memorizing is not a very good idea. So for me to like just having as you use it often, you'll gradually get to remember this formula. But it's better to remember the proof rather than this, so that you just remember the motive behind this relationship. Yeah, so hope you enjoyed this video and you can use this theorem in your geometry problems. And yeah, see you in my other videos.